kick a football or a soccer ball from ground level at an angle like this, the path of that soccer ball slash football slash whatever it is will be something like this. What's the mathematical term for that shape? Some of you have done this in math class already, some of you haven't, but you can remember the word anyways. Parabola is correct. When you go to do parabolas in math class, if you haven't done them already, maybe they make just a tiny bit more sense to you after we end up going over this. Now, this football or soccer ball, whatever it is, ends up having two components to its motion, a horizontal component to its motion like this, and a vertical component to its motion like this. The horizontal component doesn't experience any forces. There's nothing to speed it up or slow it down horizontally. So that means the horizontal velocity, whatever it is at the start, is the same over the entire trip. It's not going to increase or decrease. Now, we're talking in the absence of air resistance, right? With air resistance, it would decrease. With a wind, maybe it could even increase. But in the absence of air resistance or wind, it's neither going to increase nor decrease. Therefore, we'll describe the x component of this projectile's motion, this soccer ball's motion, using our group A equation, v is equal to delta d over delta t. Constant velocity, right? If it's not speeding up or slowing down, the only way we can describe it is v is equal to delta d over delta t. But vertically, this thing might start out with a velocity that is big, but as it goes up into the air, the velocity vertically gets smaller. Right here, what's the velocity vertically here? 0. It stops, right? Not stops, because horizontally it's still moving at the same velocity, but vertically it's not going up or down, it's just stopped. But then when it starts going down again, the vertical velocity starts increasing again. So the vertical motion of this can be described by an acceleration equation. So the y component we would describe using one of our group B equations. The one that we're going to use here is which one? There's a reason why we use this, although technically we could apply any of our group B equations. The one that we're going to use here is d is equal to vit plus 1/2 at squared. The reason we do this one is because A, it works. So let's try the one that works. Even though the other ones are valid, this one works. Let's do this one. B, it works because that's the equation for a parabola. If you've done parabolas in math class, then y is equal to ax squared plus bx plus c is really just this equation. Now, what's the strategy at this point for solving one of these problems? Some people like a strategy like this. Some people hate a strategy like this. But the strategy at this point is just plug in your numbers and see what happens. See what falls out of it. Just sub in numbers and see what happens. Okay? You're going to solve for something. And it may be what you're looking for right away. If it is, wonderful. It may not be what you're looking for right away. It might be something completely different than what you're looking for. Don't worry about it. Whatever. Like, we're not trying to solve for, no matter what we're asked for, we're not trying to solve for anything specific here. We just sub our numbers in and get something. If it's what we're looking for, good, done. Move on to the next question. If it's not what we're looking for, then let's use what we just solved for to help us get what we're looking for. So don't worry about what you're looking for right away. If you get something that's not what you're looking for, then use that to then try to get what you're looking for. All right. You did an example question yesterday, but I'm going to make up another one right now. Just give you another one right now, and we'll go through this one together. Okay, this first one for today is going to look like this. We're kicking a ball. Actually, let's change this. Let's not make it a ball going off the edge. Let's make it a bus, a pizza. Let's make it Marcos. All the way, Marcos. Marcos is running on the top of this cliff. He's running fast. He's running at 10 meters per second. That's pretty quick, Marcus. Marcus, really good, actually. 36 kilometers an hour. Good for you. He's running away from his from all these girls that are chasing him. Right? Now, I think they're chasing him because they like him. I think. Okay. Anyways, probably. Yeah. So he's running at 10 meters per second, and he realizes, there's this cliff there, but he can't stop. He's running at 10 meters per second off the edge of the cliff, and he goes down like this, takes a path like this. It's not like the old cartoons where he goes out like this and then looks down and then falls, right? Okay, that happens in the cartoons, but Marcos, a student of science, is going to follow the correct path, which is a parabola. It's actually like a half a parabola here, right? Not the full parabola that we had with the soccer ball, but still call it a parabola. Let's say the cliff is 20 meters high. Whew. Marcos, watch out. Hey, that's not good. 20 meters high. That's like over 60 feet. The good news is, Marcos, there just happens to be a pond out here that you're going to end up in. So you're going to be fine. You're going to be just fine. The question is, how far away from the base of the cliff does Marcos end up landing? How far away from the base of the cliff does Marcos end up landing? Well, we got to break this up into x and y components. It's like those relative motion problems or vector addition problems. It doesn't look like one of those problems, but it is, because he's got motion horizontally and motion vertically. I'm going to describe his horizontal motion by delta d over delta t, because it's constant velocity, and his vertical motion by vit plus 1/2 at squared, because he accelerates. Therefore, we have to use a group B equation. Pick the one that works, the one that describes a parabola. Now, remember what the strategy is at this point? There isn't really one, right? It's just plug in your numbers and see what happens. Like, just see what falls out of it. Do we know what V is? Just start with the beginning. Do we know what V is for the horizontal? What is it? 10 meters per second. Do we know what D is for the horizontal? No, that's what we're trying to find, isn't it? How far he ends up from the base of the cliff. That's the horizontal displacement. Don't know what that is. Do we know what T is? Nope. All right. That didn't help. Oh, well. Doesn't seem very useful. In fact, that step wasn't particularly useful. We just didn't know that it wasn't going to be useful. That's okay. We've just invested 20 seconds of our lives that we're never going to get back, but oh well. Let's go on to the y component. Do we know what D is for the y component? Yeah, what is it? 20 meters? Not quite, almost though. We're going to make it negative 20 meters. Why is it negative 20 meters? Because he ends up below where he started, right? What's VI for the y component? He's running at 10 meters per second off the edge of the cliff. He's not like he's running to the edge of the cliff and then jumping up at an angle or jumping upwards, right? When he goes off the edge of the cliff, he's moving at 10 meters per second horizontally. Now, after he goes off, he's moving vertically downward, right? But not when he goes off. So the vertical velocity right there is 0. I'm just going to cross it off, because 0, I don't know what the time is, but 0 times whatever the time is 0. A is negative 9.81. Negative 9.81, because we're still talking about vertical here right now, right? If this was a problem where I threw a ball up into the air, you would say A is negative 9.81. Well, it's here too then for the vertical component. Times t squared. This is a little tricky. Solve for t there. Let's say a half of negative 9.81 is negative 4.905. That simplifies it a bit. Let's say negative 20 divided by negative 4.905. Listen. So negative 20 divided by negative 4.905. Whoops. 905. 4.07 times 4.077? Well, not really, not quite. What do we got to do to get time? Yep, square root it, right. So it's going to be 2 point something. 2.0193. Okay. Oh, wait a second. That's not what I was looking for. I was looking for how far it traveled, right? Who cares? What was the strategy? Get something. Did we get something? Okay, we're winning then, right? We're winning. We haven't won yet because we haven't actually got what we're looking for, but we're on the right track. Remember what we said after that? Get something. Then use that something to get what you're looking for, unless you happen to be lucky enough to have what you're looking for right away. Let's take that time and sub it into here. How come I can do that? Like this 10 meters per second for the horizontal velocity doesn't translate to vertical velocity. This vertical displacement of neg 20 doesn't translate to the horizontal displacement over here. How come the time can go over back and forth? Yeah, because time's a scalar. Right? Time's a scalar. It doesn't matter whether it's x or y. The time is the time. So we're going to say 10 is equal to delta d over 2.0193. That's going to give me a displacement of 2 times 10 is 20.193 meters, or we're going to round that to 20 meters. Make sense? Let's do another one. Just change it around a little bit. Solve for a different variable here, okay? This time, I'll get another cliff here. But let's make it, I don't know. How high is it? Don't know. Let's kick the ball off, because that seemed a little violent for Marcos to be running off there. Even though he fell into a pool and was safe, seemed a little violent. So let's make the ball go off at 5 meters per second, okay? Going to follow a parabola. And let's say it ends 7.0 meters from the edge of the cliff. We want to find out how high the cliff is. Okay, got it? What do? X and Y, right? Every time we have 2 dimensions, we go X and Y. X component is described by which equation? What is it? Did you say something? What is it? Yeah, good. V is equal to delta D over delta T. Question number 1 on your final exam is a projectile motion question. I'm telling you right now. Question 1 on your final exam is a projectile motion question. Okay? You must, no matter what that question looks like, start off by saying V is equal to D over T for the X component, and D is equal to VIT plus 1/2 AT squared for the Y component. Now, the rest of the question might be different, but that part of the question is the same. Everybody should get at least 1 out of 80 on the final exam, because all you got to do to get at least 1 out of 80 is write down those 2 equations for question number 1 on your final exam. Got it? Don't you dare be that person that doesn't write those equations down. Okay? Everybody has got to start on it. Okay, let's sub in numbers. Do we know what V is? Do we know what V is? Yeah, what is it? 5? Do we know what D is? Oh, look at that, we do. The horizontal displacement is 7. The last one, we didn't know that. Oh, look, we can get time here. See that? Last time we had to get time from the Y component. This time we get it from the X. Time goes up by multiplying. Then the 5 goes down by dividing. 7 divided by 5 gives me 1.4 seconds. Is that what we're looking for? No. Whatever. That's fine. Let's go on to the next one, the Y component. Do we know what the Y displacement is? Nope. That's what we're trying to find, right? What's VI for the Y component? How much of that 5 meters per second is up or down? 0. 0 times time is 0. My time is 1.4. I've got to square that. Let's say 0.5 times neg 9.81 times 1.4 squared. What do we get for that? Negative 9.6. Isn't that my answer? Looking for how high the cliff is, isn't it 9.6? Really, actually, the displacement is neg 9.6 because it fell down, right? Height would technically actually be positive 9.6, right? But if you left it as negative, I'd mark that right. Is that okay? You can imagine maybe another question where maybe you've got this and you've got this, and you're solving for this. Whatever. Just sub in what you got, get something, and then take that something and get what you're looking for, whether it's displacement x, displacement y, or velocity, or whatever it happens to be. Now let's take a look at two of the courses that we had that we were working on yesterday here, questions 3 and 4 from worksheet number 9. Starting with number 3, it says a person running horizontally at 4 meters per second runs off a ledge, lands 8 meters from the edge of the ledge. Calculate the time that the person remains in the air, the distance that the person fell. So we're looking for two things here. That's fine, whatever. What's our strategy? Just get something. If it's what you're looking for, great. If it's not what you're looking for, oh well, use it to get what you're looking for. Let's draw the picture here. Always draw a picture of this. Okay, person's running off the ledge at 4.00 meters per second. Lands 8 meters. So this is going to be 8.0 meters this parabola goes for. Right here. The time that the person remains in the air. We're looking for the time here. And we're looking for the distance the person fell. So we're looking for this, right? The displacement of the person. Good? Yep. Yep. Good? So we got x's and we got y's. X is always, always, including question number 1 on your final exam, described by which equation? E equals d over t. Gotta be. No exceptions. The y component, group B problem, because it's acceleration. We're going to say d is equal to vit plus 1/2 at squared. Now, technically, it doesn't always have to be that. Technically, it can be any of those group B equations, but that's always the one we're going to start with, okay, because it's the one that usually works. Stubborn numbers, we know what v is. It's 4 meters per second, right? D is 8. Oh, look at that. Let's call for time. Time goes up, 4 goes down, 8 divided by 4 is 2. And that worked out perfect. 2.00 seconds. Hey, we just solved for something that we're looking for. Even if we weren't looking for that, that's okay, right? But we're still looking for more of the distance the person fell. Okay, let's try to find that now. The vertical displacement. What's the vertical velocity here? The up and down velocity, the start of it. Like we're not saying Vy, the y component of the velocity. We're saying the y component of the initial velocity is 0. So 0 times time is 0. And we just found the time. So let's find that now. Let's say 0.5 times negative 9.81 times 2 squared. Gives us the value of, I'm going to say 196 meters. That's quite the fall. Should be negative should be 0.5, right? Is that right? Yeah. Oh, negative 19.62 meters. That makes sense. That makes more sense. Round up to 3 digits, right? Because if we look at this, that's 3. This is 3 digits. Final answer should be 3 digits. Yeah. Okay, let's have a look at number 4 now. Cannon fires a cannonball horizontally off the edge of the cliff, landing 1,200 meters away from the edge of the cliff. Okay, here's the cannonball. It's going horizontally off, lands 1,200 meters from the edge of the cliff. Height of the cliff is 44 meters, right? We're looking for this is good. We haven't solved for this yet. The initial speed of the cannonball. Should we panic about this? We should never panic about anything. Unless there's like monsters chasing you. Then you should panic. But like in this context, you shouldn't panic about anything. Even if we've never done a question like this before, like we haven't, it's okay because we've done a question like this before because we have, just not solving for this variable. X and Y, as always. What describes the X component? Doesn't matter if we're looking for a different variable. It's still the same equation that describes it. Same for the Y component. My group B equation. Do we know V? Start over here, right? We start over here always and just sub in what we can solve for, what we can sub in. Do we know V? Nope. Do we know delta D? What is it? 1200 or 44? 1200, because this is the X component. Do we know T? Nope. Oh, well. No big one. Let's go over to the Y component. Do we know D? Yep. Negative 44. Do we know VI? 0. Right, we don't know what VI is horizontally, but we know what it is vertically. It's 0, because it was launched horizontally off the edge of a cliff. 0 times time is 0. 1/2 of neg 9.81 times time squared. Okay, so 1/2 of neg 9.81 is neg 4.905. We're going to say negative 44 divided by negative 4.905. Then we're going to square root that. And we get 2.995. So 44 divided by 4.9, square root it, 2.995 seconds. It's not what we're looking for. Is that a problem? Nah. Just take it over, sub it into the other equation. You get 1,200 meters divided by 2.995 seconds. Gives us 400.65. Get around that to 401. Holy cow. That's pretty fast, isn't it? We are launching a cannonball. Was your hand going up there?